So hopefully you have remembered there are three main principles of tidy data. Does anyone want to volunteer one? I won't make fun of you if you get it wrong. It's fine. Anyone? What's one principle of tidy data? I'm not going to keep talking until someone volunteers one. Just yell it out. Yes, it's unprocessed data. That's important. That's not one of the three things, though. Right? Each row is an observation. I think kind of more importantly than that, each variable is a column. And if you do that, you'll kind of tend to find that each observation naturally becomes a row. Now, these are kind of, I think, the two most important principles, but there's one more that I've actually defined in different ways in different places, but I'll give you points for any ideas. Any takers on this last principle? Yeah, so there's a principle around like each kind of data frame should be like a data set, but that's a little vague. So I think a nicer one is that each cell should be a single value. Now, all of these definitions are a little vague, right? Like, I mean, we know what a column is, hopefully. We can easily define what a row is. But what exactly is a variable, and what is an observation, and what is a cell? It's a little trickier, and a little bit later, I'll try and talk about some kind of recent attempts to try and make that precise in such a way that you can still actually understand what I'm talking about. But this basically is, who's heard of list columns? So a list column is a column that is a list. And what's special about a list is that a list can contain anything else. And so when you've got a list column in your data frame, that means you can have kind of one cell, something that's indexed by a variable and observation, has multiple values in it. And that's a bad thing because it's hard to work with it. And that kind of brings me to my next point. Like, why should you care about tidy data? I think there are kind of two reasons. The first is the goal of kind of the tidyverse is that once you've got your data into this tidy form, then you can leave it in that form throughout the entire analysis. You don't need to think about how do I wrangle the output of this function so that I can use it as the input to another function. You leave your data in a tidy form and the tools kind of come to you. And the other thing which I want to talk about today is that, you know, this tidy data is this like beautiful theoretical idea, but you're hardly ever going to be given a tidy data set in real life. Like, if you are, like, don't tell anyone because they'll want to steal your job. In real life, you get data sets that will surprise and amaze you at the level of creativity that's been used to record the data. So what I want to talk a little bit about today is some of the kind of tools for tidy data and some of the things I've done in the past and some of the things that I'm working on today. So, and I'm going to focus on these two today, this idea that you want to rearrange your data so that every variable is a column. And when you do that, you kind of tend to get the second thing for free. This is also a really important topic. I think it's more important today than it ever has been, because if you are dealing with data from APIs, you'll often get data in the form of JSON or XML, which are these very, very densely nested lists. And you need tools to flatten out those lists into rectangles that you can work with in R. But today I want to talk about the first. And I'm going to kind of motivate them with a couple of animations, and these animations are really not very good, but they will hopefully give you sort of the gist of what's going on without having to describe. So there's kind of two main types of reshapings that you need to do, two neat ways of changing the data. And the first one is here we've got some terrible made-up data about bakers, and then we've recorded their recipes, and we've recorded how much flour, sugar, and eggs they have in each recipe. And now for some reason we want to reshape this where, and there's no real justification for doing this data, but I'm just going to show you, we might want to like make this data longer, right? Kind of collapse, make it narrower and longer. And if we're going to do that, kind of we do this in a few steps. Like first of all, we kind of think about each person having their own little data frame. And then we're kind of rotating those data frames around. And unfortunately, my Keynote animation skills are not up to animating that very well, but you can kind of see that these column headings now become a column of values. And then we kind of like bring it back to a regular data frame. That kind of makes sense. So we're taking this kind of wide data set and we're making it narrower, which necessarily means it's going to be longer. Now we can also do the opposite of that. We can kind of go back in the opposite direction and say we've got this long data set, this narrow data set, and we want to make it wider and shorter. And so the same thing kind of goes on here. We can kind of think of each of these as being the data about one person, kind of thinking about that as a little data frame. And notice here that Harry's recipe's only got 2 ingredients. And this is important because if we're going to make this wide, now we've kind of got something that's missing here. Or to be a little, or what I prefer to call it rather than missing, because when I say missing, you probably think of a missing value in R, like an NA. This is simply data that is absent. This is data that is not present, right? It's not explicitly missing, it's just not there. Right, this is one of the things that it's kind of confusing about missing data, is we have to talk about something that's not there. And sometimes, if you're lucky, you have that explicitly recorded in your data and you can see an NA. But a lot of the time, your missing data is simply absent, right? You don't know it's missing. And I think this idea of thinking about like implicit missing values that are just not there versus having explicit missing values present in your data set is really important and something you should think about in your analysis. But in this case, we're just going to need to fill something in there, right, to make it a line. And so I'm just going to put, in an explicit missing value there, right? So sometimes when you change the shape of a data set, you change it from explicit missing values or implicit missing values to explicit missing values. And sometimes you do the opposite. Sometimes the shape of the data forces explicit missing values when there really should just be nothing there. It's quite philosophical. Anyway, so there's kind of 2 basic forms of reshaping, right? The one that makes it longer and narrower, and the one that makes it shorter and wider. Does that make sense? Okay. Took me a long time to figure that out. And so what do we call these things? Well, there's a bunch of different names. If you've used spreadsheets before, you might have used pivot tables, make data wider. Databases sometimes call this folding and unfolding. If the few of you alive today that have used Reshape, was called Melt and Cast, and Reshape 2 basically had the same names. That was called Melt and Decast. The D was for data frames. And then TidyR had Gather and Spread. And at the time I wrote Gather and Spread, they made a lot of sense to me. But a lot of people have problems with Gather and Spread. And like, to be honest, like even I find myself like having to read the documentation for Gather and Spread. And that kind of like seems like a bad sign, right? I can't remember what Gather and Spread do, and I wrote them. Like, how in the heck is anyone else supposed to? So I think this is kind of an example of like a bad design. Like the fact that Gather and Spread like don't stick in your brain, that's not a problem with your brain. That's like a problem with my brain designing these things. Oh yeah, and you know, there's like tweet after tweet after tweet of people who can't remember these things. And so today what I want to talk about is two new functions called pivot long and called pivot wide. And you might guess from the name, but pivot long makes the data set longer and pivot wide makes a data set wider. And I honestly don't know why it took me 12 years, I guess, to come up with those names, but I finally figured it out. And I think part of the reason it took me a long time was this idea that, like, is tidy data longer or wider? And that's the wrong question to ask. Like, sometimes to make your data tidy, you have to make it longer, and sometimes to make it tidy, you've got to make it wider. So these are kind of independent of tidy. These are the tools you use. I don't think it makes sense to talk about, you can kind of say this data set is longer than this data set, or this data set is wider, but I don't think it in general makes sense to talk about long data or wide data. These are transformations. You're lengthening or you're widening. So I want to talk a little bit about is these new pivoting functions. And I'm going to show you some code, and I guess so I'm going to try to program with one hand. I think I'll be okay since I've mostly scripted this. And I have large hands. So I'm going to load the tidyverse, because I always do that. I'm going to load in this data set that it's called the Pew data set. It's a survey. A little bigger. Can everyone kind of see that? I know the screen's a little small. But we've got a data set. This is a survey. And in this data set, there were two questions. What religion are you? So we've got agnostic, atheist, Buddhist, Catholic, and so on. And then how much money do you earn? And so this data set is clearly not tidy, right? Because these columns, like a column 40 to 50,000, is not a variable. It's a value. And this is a very common way to get data because people often save data in a form that makes it easy to do comparisons. And this kind of makes it very easy to compare both like within a religion and within an income. But this is no good for analysis, basically because we've got three variables: religion, income, and count. And we've stored those three variables in three different ways, right? One is a column, one's in the column headings, and one's the values of the cells. So obviously having three variables stored in three different ways is going to make your life difficult because depending on which variable you want to refer to, you're going to have to refer to it in a different way. So the idea of tidy data is to put all of the variables on the same footing, to put them all in columns. And so to fix this data set, it's too wide, right? So we want to make it longer. So we're going to use the pivot long function. And we're going to first of all say, well, what variables do we want to make longer? And here I'm using the negative sign, which just means I'm going to use all of the variables apart from religion, all of the columns apart from religion. So from 10K all the way up to greater than 150K. Then I need to say, well, I've got some, this is data, right? In the column names. I need to say, well, what is the variable that is going to become in the new data set I'm creating? And so the new argument for this is called names underscore to. This is the variable that the column names will go to, right? So this is the income variable, and then similarly, what new column should the values go to, and that's the count column. And neither of these variables exist in the current data set. And so that means we need to put their names in quotes. So tidyr kind of played fast and loose with this rule, but these new functions, if you refer to a variable that exists, it doesn't need quotes. If you refer to a variable that does not exist, that you want to create, you're going to have to put it in quotes. Now, if you asked me today, what is the equivalent of these variable names in Gather, I would not be able to tell you. I'd have to look it up in the documentation. but I am reasonably confident that I can remember this in the future, right? Because it's a little, where are the names going to? Where are the values going to? And so let's run this, and oops, that's because I guess I accidentally installed the cran version. TidyR, so I'm going to quickly rebuild, oops. Rebuild this. So I'm just going to reinstall the TidyR package. Close that again. Oops, I'm going to restart RStudio. And I'm going to rerun this code again. Fingers crossed, it's going to work. Okay, so programming live with one hand. So in there we get what we expect, right? This is now a tidy data set because each of these columns is a variable. Now there's kind of another way we could think about this, and it doesn't really make sense for this data set, but it's going to make our lives easier for more complicated data sets. And that is we can also kind of describe this transformation using a data frame or a tibble. And the basic idea here is what we're going to do is I'm going to create a tibble that has one row for each column that I want to lengthen. And we're going to have the name of the column, right? So these are just the names of the columns in the existing data frame. We're going to have which value column should that go in? Well, what value does that represent? These are all counts. And then what new variable do I want to create? Income. So in this case, this column and this column are identical, right? So this is not a very useful way for thinking about this data set, but hopefully this is sort of simple enough you can see what's going on. And so here, instead of, I've created this object I've called spec, short for specification, because this is a data frame that describes the tidying operation, right? And so I can pivot it long, and I get the same tidy data set I showed you earlier. Now, one thing that's kind of interesting about this, or neat about this, is once you have this spec, you can actually undo the transformation. So the opposite of pivot long is pivot wide, and if I give it the same specification, basically I can end up where I began. Now, why should you care about that? I don't know, but it seems cool to me. I think it's cool because it kind of shows that like lengthening and widening are symmetrical operations. And we can encode all the details we need to go in either direction or to reverse the transformation in a single data frame. And I think that is something to me that sort of makes me feel like there's something useful here, that we have this nice property of symmetry. Okay, so let's take a look at another data frame. So this is some data from the World Health Organization about tuberculosis data. So you'll see we have a few columns, basically the country encoded in 3 different ways, and the year that are, these columns are variables. And then we have a bunch of variables that look like this. And so if we scroll down, we'll see there's like a lot of them, right? But if you look at these variables for a while, you'll notice there's some kind of pattern. So can anyone spot a pattern here? There's one really simple pattern, and they all start with new underscore. Well, apart from these ones at the end, which just have new in front of them. Because of course, there's no way anyone could be consistent across all of the variables in the data frame. But this new means these are new cases of tuberculosis. And then we have a code after that, right? SP, SN, EP, and REL. And this is basically how the cases of tuberculosis were diagnosed. Then we have either an F or an M. What does that probably stand for? Gender. And then we've got some numbers like 5564 or 2534. What do you think that is? It's probably age, right? And I think we have, is this? And these are probably age groups, right? 35 to 44 and so on. So how do we tidy this data? Well, I think what we want to do, I think the key idea here is that these variable names have a bunch of data in them. And if we're going to tidy this, a good first step is to get that data out of the variable names into their own columns. And so I'm going to start again by creating the specification. And the specification, again, starts out pretty uninterestingly. We have the name of the column, the value that it's going to go into, and then this name column repeated. And you'll notice that the dot name and dot value, these have dots in front of them. These indicate these are kind of special variable names. And so what I'm going to do is I'm going to try and take this column, and break it up into the individual components. And so to do that, I'm going to use an existing tidyr function called extract. I'm going to extract the name variable into the diagnosis, the gender, and the age using a regular expression, which I'm not going to explain here, but is very concise. And you can kind of see the results here. Right now I've got a column called diagnosis, a column called gender, and a column called age. And I could do a little bit more to this, like I could say, well, I know that gender is actually a factor, and because there's a fixed and known possible set of values, age is the same, there's a fixed and known set of possible values, and additionally, those values have an order to them, right? We know that 5-year-olds are less than 10-year-olds. That's clearly not the same. That's clearly not the case for genders, right? Well, hopefully it is clear that that is not the case for genders. Okay, so basically when I do that, not much has changed, but except for the type of these variables. But behind the scenes, I've more accurately recorded what sort of data this is. These aren't just random strings. These are known possible sets of values, and for age, they're ordered. And now again, I can pivot this. I want to make it long, right? And I'm going to use this specification so that pivot long is going to look at this variable, new underscore sb underscore male04, and for every entry corresponding to that variable, it's going to put diagnosis sp, gender m, and age 0 to 14. And so when I do that, I now get a nice tidy data set. And I think this idea that often when you've got data that's like too wide, what's happened is you've got data stored in the variable names. And you may have multiple variables stored in the variable names. And kind of explicitly thinking about that and encoding that in a data frame is a very powerful idea. Okay, one last challenge. So this is some data from the World Health Organization. We have a country. It's kind of obvious what that is. We have an indicator. A little hard to tell what that is, but we'll come back to that later. And then we have a bunch of columns, 2000, 2001, 2002, and so on. So do you think these are variables? Probably not, right? They're probably years. And so I don't know what's going on here yet, but I'm going to fix this most pressing problem. My data is too wide, so I want to make it longer, so I'm going to use pivot long. And I'm going to pivot all the columns from 2000 to 2017. What should the names of the variables go to? They should become the year. What should the values go to? Well, we don't know yet. I don't know what these values represent. So I'm just going to leave it as the default, which the default is just value. So this is tidy, but what's this column and what's this column? So I'm just going to count this column up just to see what's there. And you'll see it contains 4 values. And if you know anything about the World Bank data, which you probably don't, but I do, they made this data set, you will know that POP stands for population, GROW stands for growth, so this is the population growth, this is the total population, URB stands for urban, so this is the urban growth in the urban population, and this is the growth in the, sorry, this is the total urban population. So these are things that are actually variables, right? Population growth is a variable, total population is a variable. So now we have this opposite problem, that our data is too long, right? Because these are occurring in rows and we want them to occur in columns. So to fix this problem, we need to make the data set wider. And so we're going to use pivot wide. And so pivot wide has kind of the sort of the opposite arguments to pivot long. So remember in pivot long, we specified where the name should go to and where the value should go to. In pivot wide, we do the opposite. We say, where should the names of the columns come from? Well, it should come from this indicator column. Where should the values come from? They should come from this value column. And because these variables exist, they don't need quotes around. So if we run that, and we now get a tidy data set because each of these columns is a variable. So the goal here is firstly to help us. So the first goal is to make pivot long and pivot wide hopefully memorable, which I think they are because they kind of describe what's going on. They're making the data longer or they're making the data wider. And I kind of proved to myself, so when I talked about this last week, and I kind of proved to myself that these names are bad because I actually I made this table incorrectly. I had half the entries in the wrong place. So like I cannot reliably remember which direction spread and gather go in. But I think I can remember that one pivot long makes it longer and pivot wide makes it wider. And if you disagree, please tell me as soon as possible before this gets locked in. And then the second goal is to hopefully make these argument names more understandable as well by using like names and values, which do a better job of, like if you look at the help for gather, say, you'll notice it uses key and value, which kind of made sense to me at the time, and I can get myself in the mode of thinking where that does make sense, but it's very hard to explain exactly what key means in this context. It's not key like you unlock a door with, right? It's key like a database key, which, to be honest, I don't know if we can find the etymology of this quickly. Is this a British, English, small piece of metal? No. Each of several buttons? No. A thing that provides a means of achieving or understanding something. Okay, that I guess is it. Like that's like an answer key. Like it allows you to look up something. Okay, that's good to know. And I don't know if these have. One thing I've recently become aware of, and it's Old English, which I think means if you're a German speaker, it should be more understandable. I've recently come to realize, like I discuss a bunch of function naming things with people on my team. And I kind of only recently realized, like when I'm talking to Lionel, who's Belgian and speaks French, like when we're discussing the names of possible function names, if there's two options, and one option has like an Old English derivation, and one has like a French derivation, he always prefers the French derivation. So if you've noticed, like tidyverse APIs are sliding towards more like French words. it's because of him. But now that I've noticed it, I'm like, oh, that's why. That was a little bit of a digression. Okay, so how are we going for time? We're probably at time. Or you want me to keep going? Let's do a quick show of hands. Who wants me to keep talking? Okay. If you don't want me to keep talking, you just leave now and be no embarrassment. Okay, so the next thing I want to talk about is tidier data, which is some things I've been thinking about. I'm going to show you 3 data sets that are technically tidy but make me feel uncomfortable. And it will hopefully make you feel uncomfortable too. And has anyone here heard of Codd's third normal form? Okay. And how many of you understand Codd's third normal form? No one's willing to admit that. Or one person is maybe. So these, if you know Codd's third normal form, if you've ever taken a database class, you've probably heard of this. I am going to basically attempt to explain to you Codd's third normal form in a way that you can understand, because I have tried to understand Codd's third normal form and I found it extremely difficult. I would encourage you, if you want to read some like, I don't know, truly horrific things, read the Wikipedia page for this. Because I think the thing that makes Codd's third normal form most awful is it uses very specific technical jargon where all of the words are simple words that you are already familiar with, but have very specific definitions. So you can read these sentences, like you understand every single sentence, every single word in the sentence, but the sentence as the whole like means nothing to you. So I'm going to attempt to kind of describe Codd's third normal form to you using 3 examples that will hopefully make you uncomfortable. Okay, so the first one is a built-in data set in R called DNAs. This data set name, you notice up here I wrote DN with a capital A because when you write DNA with you normally write DNA with a capital A, but in R it's D in lowercase a's, which drives me crazy. But, okay, so we've got some data. This is an ELISA assay, which I have forgotten exactly what this means, but basically we have got, and I apologize to in advance for my definition for anyone who actually knows what an ELISA assay is, but basically we have got some like DNA type thing, and it is going through some system along with some other chemical type thing, and we have the concentration of that chemical type thing. And over time, that chemical type thing is increasing, and we're kind of measuring the density, which tells us something about the DNA. So what I want you to do is take a look at this. That was a very brief description and very confusing, but I want you to take a look at this data set and what makes you uncomfortable. Talk about it with your neighbor. You've got 1 minute starting now. Okay, time's up. So, what makes you uncomfortable about this data? Anyone want to volunteer? Yep. Right, so we've got a run, we've got a concentration, and you might kind of wonder, like normally concentration is something you measure, right? But that's clearly not the case here, because the concentrations are always the same in each pair. And if you look at the other runs, which don't fit on the screen. You'll see that's always these same concentrations. So this is a property of the experimental design. And you'll notice for each run, for each concentration, we've actually got 2 measurements, but there's no way to identify them here, right? There's no combination of variables in this data set that allow us to point to one of those observations. And so I'd say ideally you actually want a data set that looks like this, right? Where you've also recorded the rep. And I've drawn a line here because I think that there's a useful distinction to make that typically you have 2 types of variables in the data set. These are what I call key variables or identifier variables. These are things that are fixed by the design of your study, right? You can write all of these down in advance. And these are the measured variables. These are the things that you're actually recording when you collect the data. These variables just identify an observation. This is actually what you're measuring. Okay, next data set. This might make you uncomfortable for a different reason. This is Billboard's top hits in 2000, which hopefully needs less explanation. So again, I want you to look at this data set, talk it over with your neighbor. What makes you uncomfortable? You have 1 minute, starting now. Okay, time's up. So what makes you uncomfortable about this data set? Nothing, really? Okay, I'm gonna, someone said they're uncomfortable with Baby Don't Cry being in the top 100. Okay, I do have a, what about this data set? I'll flick back and forth so you can see the, you see the difference? See the difference? Look, here we've got 3-pack. So what makes you uncomfortable about this data set? Like, Baby Don't Cry is a song, right? And one person wrote that song. And the person who wrote that was 2-pack. Right? The fact, we want to record a fact about this song. The fact is that the author of the song, the artist of Baby Don't Cry, is 2-pack. And how many times do we have that fact recorded in this data set? Like, we've got it recorded multiple times. And when you've got a fact recorded multiple times, like if you're analyzing data and this happens, like what the heck are you supposed to do with this? Right? You've got some inconsistency that you need to resolve. And so I think this data set is actually 2 data sets, because we've got facts about the song, the artist, the date it entered the Billboard, and the year it was produced, and we've got information about the song in each week, i.e. what was its rank on the Billboard Top 100. So here we've got one key variable, right? This, we can identify each song by its name. That's not a great identifier in general, right? Because the same people do covers of a song and stuff. But in this data set, it works. And in this data set, in this one, we're identifying the information about either the song, identified by the name of the track, and the week. And what we recorded is what its ranking in the top 100. Yeah, and these are, oh, that's a good, let's ignore that. I'm going to ignore that point. It's a very good point, but and completely destroys this example, but it doesn't really matter. I'll fix it in the future. So okay, one more data set. Now this is some data about house construction in the United States, and as you might guess from the formatting, it's in an Excel spreadsheet. And I have kind of this theory about Excel spreadsheets, and that is like data in an Excel spreadsheet can never only be untidy in one way. It has to be untidy in the maximum possible number of ways. So not only, we've got merged column headings, we've got a bunch of dots, we've got this column which contains both year and month, right? I'm just gonna ignore all that. Also, if you look at the sheet, each sheet contains one table for seasonally adjusted data and another table for not seasonally adjusted. And then if you look across all of the sheets, one has permits, one has authorized but not started, another has construction that was started, some that's actually under construction, and then completion. So we've got, like 6 variables here stored in like 6 possible ways. I'm not going to expose you to the full horror of that. I have kind of tidied this data set up. And I should point out, I forgot to point this out. This data set is tidy, right? Because each column is a variable and each row is an observation. This data set is also tidy because each column is a variable. We might argue about whether a row is an observation or not, but it's basically tidy. And here I have another tidy data set where we've got the year, the month, the number of units, so this is the house size. Is it a single family dwelling, 2 to 4 people, or 5 plus, basically an apartment building, and the region, and then the number of houses. So again, when you look at this data set, you have 1 minute for it to make you uncomfortable. Okay, time's up. So what makes you uncomfortable about, actually I should ask, let's do a quick round of hand. Who feels uncomfortable with this data? So if you feel uncomfortable, why? So total, which actually I need to remind myself to, yes, that's true, but it's not what I mean, so I'm just going to delete that. So you're totally right, but that was not what the point I was trying to make. So what leaves you uncomfortable with this data? Summarize, yes. Right? Either region is missing or unit is missing. So I don't have any information about the number of apartment buildings built in the Midwest. So I don't actually have a single table of data here. I've actually got 2 tables that I've kind of rammed together. Right, I've got one about the number of houses built in each region, and I've got another data set that has the number of houses built of each building size. And so these 3 examples attempt to get at the 3 principles of Codd's third normal form. And I'm going to just skip these because they're not very good. I'm just going to go back and kind of explain the principles to you. So in this case, the first principle is that you want to have a set of variables that allows you to identify each observation uniquely. And these variables, I think, are usefully called the key variables. They are like this, that's like the definition of key that I now know. These allow you to like identify an observation and then look up the measurements you made on that observation. Right, so these are the keys, these are the measurements. So you want every data set to be able to uniquely identify each observation using the variables. Then the problem with this data set is, what's the key? Well, the key is probably the key is track and week. And you want every fact to be related to all of the keys. So here we have a fact, like the artist of this song. It's only related to one key, right? The artist of the song does not change from week to week. That's another thing you don't want. And in this last one, you want every measurement to kind of use all of the keys. For in this case, we've got 4 keys, right? Year, month, units, and region, but each fact is only ever about 3 of those keys. It's either about year, month, and units, or year, month, and region. That kind of makes sense? It makes sense if I... And so basically what I'm working on currently is trying to turn those 3 ideas into sentences that like stick in your brain without having to, and I think what I've currently done is I've ended up in a slightly similar place to what I complained about Codd's third normal form, that you can understand each of the words in these sentences, but unless you know the specific technical meanings, you can't make head nor tail of them, right? I mean, I assume everyone knows what each is, and what measure is, and should, and be, and are, and property, and are of, and all of the keys, right? None of these sentences are hard to understand because you don't know what each word means, right? Even if English is your second language, like these are all like pretty common words. The problem is I have taken common words and endowed upon them very specific technical meanings, which until you have like internalized those meanings, make this very difficult to understand. So this is sort of what I'm thinking about at the moment. It took me, like, we go back to the definition of tidy data. This seems like so simple and so obvious. And it seriously took me like 5 years to come up with this. And then like another 5 years to kind of notice, well, if you do this one, most of the time the others follow automatically. So that I can now say, if your data set is tidy, it means every variable is a column and every column is a variable. And I think you can kind of understand that because you have some notion, like column is easy, and you have some notion of what a variable is. If not in general, for the specific data set you are trying to analyze. And what I am trying to do at the moment is kind of come up with some way of describing these problems so that you can kind of identify them in your data and then couple that with tools you can use to actually remedy these problems. So the other thing I wanted to show you very briefly is this diagram, which I drew in kind of a bit of, I don't know, insanity or genius, it's hard to know the difference, which I'm calling very grandiosely the grand unified theory of tidy data. And I'm not sure, since I wrote it up now, I'm like, I don't know if I like it that much, but the other thing that I kind of haven't talked about today, so we've been talking about this pivot wide and pivot tall, right? If you've got a long data set, you can make it wider, and if you've got a wide data set, you can make it longer. This diagram is from a previous era where I thought briefly it was a good idea to call it tall rather than long, but disregard that. You will notice there are some other more esoteric looking data frames in here. So here we have a data frame that contains other data frames inside of it. Again, this is one of these ideas where I'm like, that's either a really amazing idea or it's a really terrible idea or possibly both. But I'm now fairly confident this is actually a really nice way of representing your data when you are now thinking about groups of data as being kind of an observation. And this, I think, is particularly useful because when you have a data in this form, it's now natural to think, well, I could have another column where I have a model for each of these things. Because a model is just a data frame plus some model specification, right? So you can think about another column, which is the model, and then you could think about another column, which is the predictions of that model on that data set. And so I think this nested data is really useful when you start kind of thinking about these kind of bigger aggregations of data, or if you're doing bootstrapping or resampling, this is a really useful form. Another form is this idea, which I discovered fairly recently, that in R, a column of your data frame can be another data frame. And I'm going to leave that to sink in while I slowly, and I'm going to put the microphone down and type this in a second. But I'm just going to show you an example of a data frame. So here I have a data frame that has one column and 3 rows, and I'm going to add another column to it, and that column is itself a data frame. Oops. And that's because I can't count. Okay. So I have a data frame that has a column that is itself a data frame. And hopefully your minds are exploding right now. If you print it, base R kind of gives you these confusing variable names. It's a little easier if I turn this into a tibble, because tibbles are better printing methods in this case. Not perfect, but it kind of gives you the sense that we've got a data frame inside a data frame. And this is, again, I'm like, is this a good idea? It's possible. Like, Hadley was so concerned with what he could do, he didn't worry about what he should do. And I thought about that for a while. Like, this seems like a really cool feature of R, but like, you should never, why would you ever use it? And then I like drew a picture, and you'll notice in the picture, this is a data frame column that contains another data frame, and here I've drawn it just by merging the cell header. And judging by what people do in Excel spreadsheets, this is a very, very, very common way to think about data, and it seems interesting to have a natural way to express that in R. I'm still not sure whether this is a good idea or not, and whether you want to keep your data in this form, but it's certainly interesting to think about having a better way of representing the type of data people often create in spreadsheets. So this is sort of how I spend a lot of my time when I'm kind of thinking. This is what I sort of think about as research. I'm just drawing a lot of pictures and drawing arrows between them and wondering like, and then I start thinking, well, I've drawn arrows between almost everything here, but there's no arrow between here and here. Like, should there be? So I drew myself this picture to convince myself that there should not be, that this is actually, this diagram is a triangular prism, and I don't know what that means, but that justified to me why there's no arrows between some of these things. Anyway, that's my kind of research process. So that's basically how I wanted to finish. If you want to learn more about these new pivoting functions, and I would really love people to try them out and let me know if they don't stick in your brain or they're hard to use, because now is the time to give me that feedback before A, it gets into a released package, or B, I fall in love with these functions and then ignore any evidence to the contrary. So please take a look. It's in the development version of the tidyr package. You can try them out. They work. They do a bunch of other cool things I didn't show you today, using some ideas from some other packages in R that have advanced the state of art of reshaping. You can try them out. They're kind of like slow. It's basically a proof of concept, but it works, and I think it's pretty cool. So please try them out, and please let me know what you think. Thank you.
So thank you, Hadley. Any questions from the audience? So maybe we could turn on the Mentimeter. Or do you already have some questions right away? We even have 2 mics.
I'm just going to give one small definition. A question is a single sentence that ends in a question mark.
So,
when you're nesting the data from like a data frame into a data frame, how deep can you go?
You can keep going forever. I don't think you should, but you certainly can. And similarly, like you can have a data frame column inside a data frame column inside a data frame column that contains a list of data frames that contain data frame columns inside of them. Yeah, and I'm sort of interesting to think about like when is that a good idea? I think really, but there might be some case where that is a good fit.
So hi, Hadley. Thanks for the talk, very nice. I like the feature where you present basically we split up the table. We have them like very tidy and smallish and separate the different values. Then how do you keep the tables together? Because they only make sense when they're together. I mean, one is the artist and the track, the other one is the week. And if those are separated, they don't make sense. And this is the beauty of having a single data frame, even if there's redundancy, you have it all in one data frame. And if you have several one of those tables, imagine now having 10, how to track which one fits to which one. It sounds like a database in the end, a normalized one.
Yeah, so that's so the question is basically like now you've got like you had one problem before and now you've got 2 problems, right? Because you've got 2 data frames. And then there's also this problem of like, well, everything in the like if you want to plot this data, like ggplot only takes a single data frame at a time. So how do you plot this? I suspect this is kind of where like database theory and data science kind of diverge. That I think it is really, I think when you're doing a data analysis project, I think this probably makes sense as an intermediate form because it allows you to check for inconsistencies in your data. But I suspect you'd go from your raw data, go to this form, and then go back to this form. But because you're now confident because each fact was recorded in one place. There is also this sort of, I think there's an interesting kind of statistical thought here too, which is when you fit this in a model, like what is kind of counting as an independent observation here? And it's not really, these are not independent observations, right? They're repeated. And it would be nice, ideally, if the model that you're using kind of understood that. And it seems to me like there must be some connection between this and hierarchical models, but I don't know enough about them. Someone should figure that out.
Just one quick question. I'm a big user and big fan of the gather function, the spread function as well. And I've never understood why this syntax with the minus to keep the variables and not the group by. Because it works with the spread function, the group by, but not for the gather.
I have no idea either. I'm trying to think. Yeah, I think so. The sort of the interesting, I think, connection between the two is you often typically, or you almost always group by key variables. Not 100% of the time, but you normally group by key variables or some subset of your keys. And so it would make sense if, so it would make sense for tidyr to know that from dplyr. And I think there is an issue in tidyr for me to think about that, but has not been fully considered yet. I should also mention like gather and spread are never going to go away. They'll just like stay unchanging for the rest of eternity. So your existing code is not going to change, but my hope is these new functions are easier to use and you'll just switch to using them fairly quickly because I think they're quite a lot more memorable.
So since the talk was a bit longer than expected from Hadley, but again, thank you for it. It was great. I would suggest to, skip panel. Yeah, and we had just had before collected a few questions for Hadley. One was, where do you see R and RStudio in 5 years?
I wish I could answer that question in 6 months' time, but I cannot. My hope is just that it keeps kind of getting better, more popular, more people using it. I think my kind of hope for the tidyverse in kind of the shorter term, like the next year or two, is just to kind of not add a bunch of new features, but just to add a bunch of kind of smaller stuff like this, making things a little bit easier, making things more consistent. I think for sort of RStudio as a company, as we get larger, I think you'll see us kind of continuing to sort of, we are 100%, we love R, and we're 100% behind it, but that does not mean we don't also love other programming languages. So I think the other thing you should sort of expect to see, we've seen this in RStudio, it's got great SQL support and Python support. That's just going to get better and better over time. So that as an R user, your life working with your colleagues who love other programming languages just gets easier and easier and easier over time.
There are other programming languages. No, joking. Another question was regarding Ursa Labs. We talked about it earlier, and what do you see in Ursa Labs, or how will this develop and be integrated maybe into the tidyverse, the Clier, and so on? So what's your take on this?
So Ursa Labs is a project led by Wes McKinney, who is the creator of the Pandas data manipulation. It's kind of the dplyr of Python. And Wes is working on this project called Arrow. And the basic idea of Arrow is to sort of sit down and think about how should we represent kind of data science type data in memory. And this sounds like kind of a boring project, but the payoff is that if we can kind of all decide on one way to represent data in memory, then when you're working on a large data set, you can store the data in memory somewhere, and then Python can work with it, and R can work with it, and Julia can work with it, and JavaScript can work with it without having to copy it between languages. So the idea is to kind of think about how can we make it easier to collaborate on a data science project between different programming languages. And then the other component of this is why is Pandas so fast for data manipulation? It's basically the same reason that data table is so fast or dplyr is so fast, i.e. it's all written in C. And so if the way you write fast Python code is basically the same way you write fast R code, by writing C code, why don't we just all write the same C code and share that? And that's kind of the idea that on top of this memory format, we can have some kind of compute engine. People work really hard to make the C and C++ code as fast as possible. And then on top of that, we write Python libraries and R packages that take advantage of it.
So do you see then R and Python just as user interfaces to those kernels? Or?
Yeah, I think you could imagine them that way. I think that's a little, I don't know, I think people have more emotions tied up in their programming language choices than a user interface. And I think there are sort of bigger thoughts, but that's kind of the idea.
Okay, so if there are not any more questions, of course, we also have some little networking session where you can ask and get together. So thank you again, Hadley, for coming to us and joining the R Meetup. We're very happy to have you here. And yeah, thank you.
Thank you.
And maybe it's my pleasure now to open the beer and wine bar.